Today you are going to be using the area to make decisions. And the essential question is, after finding the area of a figure, can you use that information to draw conclusions? So when it comes to real life scenarios, finding a figure's area and using that information can save you time and money when making decisions. And we related this back to the Hopkins patio problem, where I didn't want to order too much tile because then I would have an excess amount of tile and I wouldn't know what to do with it. And I wouldn't want to order a small amount of tile, an amount of tile that was less than what I needed because I didn't want to, have to take another trip down to the store to get more tile. So that's why it's important to be accurate, and that's how it will save you time and money. So our first example is that Luz is planting a garden with the dimensions shown below. She wants to put a thin, even layer of mulch over that entire area of the garden. The mulch costs $3 a square yard. How much money will she have to spend on mulch? And you'll see there's a little hint right here, 3 feet equals 1 yard. So that means I'm probably going to need to use that. Oh, and I see why now. The mulch costs $3 a square yard. It says square yard. And the dimensions down here are in feet. So I'm going to show you one possible way that you can utilize to figure this out. Okay, and of course there's many ways to solve any math problems. And you'll probably come up with another way to figure this problem out once we get to the notes on the third page. Okay. So anyway, what I'm going to do is I see that it's in feet. I see there's 3 feet in 1 yard, and the mulch is sold in square yards. So what I'm going to do is I'm just going to go ahead and convert these feet to yards right now, and then I'll take the area of that. So I have 8 feet, and to turn that into yards, I would just take that 8 feet, and since there's 3 feet in just 1 yard, I'm going to go ahead and divide that by 3. Okay, 8 divided by 3, you can keep it a fraction, or you can make it a decimal. And if you're making it a decimal, I prefer if you you try to, let's go ahead and round it to the nearest thousandths place. Okay. So that's the length from here to here in yards. Okay, and then I see that that's 7 feet. This was also 7 feet, so I don't really have to go through that division right now. I could just copy that down. So this length right here is the same. Oops. I'm rounding to different places. Sorry. Okay, and then this might look confusing to some of you. It says 14 feet, and you might assume, oh, it's from here to here, but that's this entire length right here is 14 feet. And if this is 8 feet, then that would mean that this length from here to here is 6 feet. So there to there, that's 6 feet, but I'm not interested in keeping it in feet. So what I would have to do is I would have to go 6 feet and divide that by 3 in order to get how many yards it is. So that measurement right there is 2 yards. Okay, and the height of that triangle is 4 feet, but to convert that into yards, I would go 4 feet, and I'd divide that by 3, and I'd end up with 1 1/3. But I'll round it to the nearest, let's round to the nearest thousand, okay, yards. Okay, we're not done yet, because we need to figure out the area of this garden, so we can figure out how much money Luz is going to spend on mulch, okay? So to figure out the area of this garden, it really stems back to your notes from the other day in the Hopkins patio project. We have a composite shape here, and we want to divide it into probably the square and this triangle right here. So to find the area of a triangle, you would go 1/2 the base times the height to get this area, and then we'd need to add this area of this square right there, and the area of a square would be length times width, and that would give us the area of that shaded region. Okay, so I'm going to go, yeah, we got that 1/2 is constant, and the base of that triangle in yards is 2, and the height of that triangle in your yards is this. And we're going to add that to the length times the width. So the length of this, what is that, square? This. And that, when I calculate that all out, that's going to give you the area in square yards. Okay, now it's just really a matter of just plugging it into your calculator. But right here I see I don't need a calculator because I see that half of 2 is just 1. So this is 1 times 1.333. So that right there is that. And this right here, when I multiply this times this, that's about 7 and 11/100. So that would give me, when I add those together, that area of that composite shape is this, 8 and 44/100 yards squared, or you could say square yards. But again, we're still not finished because it states that mulch costs $3 a square yard. Okay. So I'm going to take those yards, 8 and 44/100 yards squared, or square yards. And I know that 1 square yard is $3, but there's 8.44 square yards. So I'm going to multiply it by $3 per square yard. And when I multiply that times that, I would get $25.32. Okay? So that right there is the answer. Oh, I should probably explain, like, you know, when you're studying for your quiz, I want to write down to the side right here, like, why we did that. Why we can do the conversions right here. So you remember. Since the mulch is sold in square yards, we converted the dimensions of the garden from feet to yards. Your summary asks, what's the area formula for a triangle? So Ian needs to paint the shaded region. The 1 jar of paint he has covers 2 square feet. However, he only has half the bottle left to use for this job. Does Ian have enough paint? Why or why not? And here's the hint. So I'm seeing that it's measured in square feet. It's measured, you know, in feet, and these units are in inches. So I'm going to just go ahead and convert these inches into feet. Okay. So for this one right here, I would take 8 inches and then divide it by 12 to get the feet. And then, let's see, this one right here, 11 inches divided by 12 to get the feet. And then this guy right here, 9 inches divided by 12 to get the feet. And then this right here, 6 inches divided by 12 to get the feet. So I'm going to show you why we did that. You know, this is one of the ways to do this problem. I'm sure you could find another way. Since the coverage, you know, the paint coverage, we converted the dimensions of the figure from inches to feet. And then found the area using those dimensions. Okay, so to find the area of just the shaded region, you would take the area of the larger rectangle, subtract the area of that smaller rectangle to get the area of that shaded region. A student in class today said, hey, it's kind of like finding the area of a donut, sort of. Okay? So you'll take your length times width of that larger rectangle, subtract the length times the width of the smaller rectangle, and that would give you the area of the shaded region. So length times width of the larger area, so I'm going to use it in feet. And subtract the area of that smaller rectangle. And that's going to give us the area in square feet. It's the area of the region in square feet. Okay, now all you gotta do is just make sure you type it in your calculator correctly, unless you're able to do that in your head. And the area in square feet is this. Okay, so looking up here, it does say he only has half of the bottle left to use. Okay, so if it covered 2 square feet, half the bottle, let me think about this, half the bottle would cover, wouldn't that cover half a square foot? I'm gonna have to look that up again because I'm trying to think. Here's how I pictured it. So the way it currently covers it right now, it's 2 square feet. So it would cover like 2 feet this way, 1 foot this way. So it would cover right here. This area is 2 square feet, okay? But he's only got half the bottle, and you would think that half the bottle would cover half of that area. So I'm assuming it would cover 1 square foot. So it appears that he's got enough for this, because if he's only needing to cover 235,000 square feet, and he's got enough to cover 1 square foot, then he does have enough paint. He'll have extra paint. He'll even have extra paint. Okay. Next question. Leah needs to paint this wall. She knows that 1 can of paint covers an area of 24 square feet. What's the fewest number of cans Leah can use to paint the wall? And it gives us the hint that 1 meter is about 39 inches. So they're giving us a hint, meaning, hey, there's probably going to be some conversions on here. Oftentimes in assessments, they're not going to give you a hint unless you're probably going to be, you're going to be using it. Okay. So I'm seeing that the paint is in square feet, this is in meters, so that's kind of a couple of conversions right there, because they only tell me that 1 meter is equal to 39 inches. So here's how I would kind of start my conversions. So since the paint coverage is measured in square feet, we're going to convert the dimensions from meters to inches to feet. Okay, so I'm just going to go ahead and do that before finding the area. So let's see, I'm going to start right here. 1 meter equals 39 inches. If there's 7 of them, I need to multiply that 7 times 39 to get 273 inches. Okay, but this is measured in feet, so I'm going to go from here, 273 inches divided by 12, and that's going to give me the feet. So this length right here is this many feet, which means that this length right here is going to also be that many feet. Because I see that they're the same. Alright, so let's see, I would probably, to find the area, I'd cut it up into that square and then this triangle. Well, the base of the triangle is also this amount, so I need to figure out this height. Well, if this is 7 and this whole thing is 11, then I know that this right here is 4 meters. I'm trying to think of a good way to write it without making it too cluttered. That's 4 meters, okay? And we gotta take that 4 meters and times it by 39, because there's 1 meter. 1 meter is equal to 39 inches. And that would give us 156 inches. Okay, then we'll take that 156 inches and we're going to divide it by 12 to get the feet. So this height of that triangle is 13 feet. Alright, let's go ahead and find the area of this wall. Let's find the area of the triangle first. So it's going to be 1/2 base times height, and we're going to add to it the area of that square, which is length times width, and that's going to give us the area of the wall. So 1/2, the base of that triangle in feet is 22.75. We'll multiply it by the height, which is 13. We're going to add it to the length times the width right there. The length and the width. It's like this. And that would give us the area in feet squared, because that's what the measurements we used. Or you could say square feet. Okay, now it's just a matter of just plugging it in correctly into your calculator, or doing it in your head correctly. And this one, when I typed in my calculator, it wasn't that long of a decimal, so I just wrote the whole thing just to be more accurate. You can round it if you want. I won't mark you wrong, but it's not even that long. It's more accurate if you keep the whole thing before you get your answer. I mean, if it says to round your answer at the end, then that's for surely what you want to do. But until I get to my answer, I'm just going to go ahead and keep what I see on my calculator. Okay, so at the very end, I'm going to round it. Okay, so that's how many square feet that area is for that wall. But we're not quite done, because it says here that 1 can of paint covers 24 square feet. Well, this is how many square feet there are. So you're going to take that amount of square feet. And you're like, well, how many cans do I need? I know that each can covers 24 square feet. And so that divided by that would give me approximately 27.73. And since it's cans, I can't buy like 0.73 of a can, so Leah's going to need exactly 28 cans are needed. For the summary, how do you find the area of a square or rectangle? If there's not enough room right here, start your writing right up there, okay? Now we're going to talk about the effects of enlargements and reductions on area. So understanding the effects of enlargements on area is useful when it comes to designing and planning projects. Since people often draw scale models before creating final projects, knowing how the model's area is impacted by a scale factor is important. So in these examples, the original shape is represented by a lowercase letter, and the new shape is represented by uppercase letter. A scale factor of 2 was used, so they're telling us that information. Scale factor of 2 was used to enlarge each shape. Now, if the scale factor is a number less than 1, a fraction, then we know that the shape will get smaller. But since this scale factor is greater than 1, we know that the shape gets bigger, as you can obviously see. So examine what a scale factor of 2 does to each shape's side lengths and areas. So I see right here, for everything, we're multiplying by 2. So 3 times 2 to get 6, 1 times 2 to get 2. So the area of this one, 3 times 1 is 3. The area of the new shape is 12 centimeters squared. Okay, and let's see here. We're going to multiply all these side lengths by 2 by that scale factor. So it goes from 3 to 6, 1 to 2, 2 to 4, 1 to 2. This is, these are proportional shapes. Here again, we're multiplying all those side lengths by 2. Okay, let's go ahead and see how this impacts the areas. So I gotta find the area of this real quick. The area of that is 3 centimeters squared. Area of this is 2 centimeters squared. Area of this is 12 centimeters squared, because I'm going 6 times 2. 4 times 2 is 8 centimeters squared. Oh, this is weird. I'm gonna go like this. So that's 4 centimeters squared. That's a 1 centimeter squared. This is 1 centimeter squared for the area. This is 16 centimeters squared for the area. 4 centimeters squared, 4 centimeters squared. Okay, so let's see how the area was impacted. The area for here went from, let's see, 3 plus 2 is 5. 12 plus 8 is 20. Oh, it went from 5 to 20, the area. This area went from 3 to 4. This area is going to go from 6 centimeters squared to 16, 17, 18, 19, 20, 24 centimeters squared. Okay, so with the side lengths, we just multiplied everything by 2 to get the new side lengths when we had a scale factor of 2. But look what happened to the area. What did you multiply by? Okay, and I'm going to show you. You actually multiplied by, you multiplied by 4. But basically, you're multiplying by that scale factor to the second power. Okay? You're multiplying by the scale factor to the second power. 2 to the second power is 4. Here, you're multiplying by the scale factor to the second power to get your new area. So what did you notice about the new figure side lengths? Well, they were 2 times the length of the original. Oops, I'm trying to color code it so it helps your learning. They were 2 times the length of the original sides. Okay, so basically we took that original length and we multiplied it by the scale factor, which was 2, and that would give us the new lengths. Okay, what did you know about the new figure's areas? Well, they were 4 times the area of the original.
Hello. Oh, that's a good.
Hi.
Good.
So you take the original area, and you're going to multiply it by that scale factor. You want to keep the scale factor consistent, but when you're finding that new area, you have to square that scale factor. Because think of it, areas like square units, so that's what you got to do. You want to square that scale factor to find the new area. If you want to triple this figure's area, what should you multiply the original area by? And I have a typo. You need to put, what should you multiply the original area by? Okay. So if we want to triple the area, we need to multiply it by the scale factor to the second power. Okay, the scale factor to the triple area. There's a scale factor, you want to triple it. Or 3 squared is 9. Okay. So what would be the new figure's area? Okay, there's 2 ways to do this problem. One way that you can do it is doing this way. Multiply the original side lengths by 3 first, Then find the area using the adjusted links. Okay, another way that you can do this is find the area of the original and then multiply that area by 3 squared to triple it. Go ahead and do either one of those. Okay. So I'm just going to draw just a quick little shape that's supposed to look like that. So I got to multiply the original side lengths by 3 first. So that would bring this to 18 yards. This whole side would be 36. Then this whole thing right here would be 36. So this would be 18 yards, 18 yards. If you're wondering how I got that, I just multiplied everything I saw by 3 because we wanted to triple it. And then once I found the area of that, you'll take this times this to get the area right here. And you'll take this 18 times 18 to get the area right here. And your area using this way would be 972 yards squared. Okay, or this way, you can find the area of the original. Use the original length, so 12 yards, 6 yards, 6 yards. And then finding the area of each of those and adding them together. And I would get 108 yards for the original, yards squared. But you got to multiply it by 3 to the second power. Let me make sure I did that. And then you would get, yeah, same exact thing. Okay. Okay. Well, what will this shape's new area after using a scale factor of 1/2? So a scale factor is smaller than 1, so I know it's going to make it smaller. So one way that you can do this is to multiply the original side lengths by 1/2 first, then find the area using those adjusted lengths. Okay, or the second way that you can do this, that I'm going to show you, is you can find the original area, then multiply that original area by 1/2 to the second power to get the new area. That's this area. Okay. So here's what this would look like. Okay, and so once I found the area of this, I got 17 and 25 centimeters squared. And for this one, using finding the original area, oh, that's a horrible drawing. And when you find that, you would take that original area, which is, I think it's 69 centimeters squared, and you're going to multiply it by that scale factor to the second power, and that would give you the same exact answer. Okay? I want you to tell me which problem was the most challenging for you. Then I want you to go back and review how to do that problem so you can get better at it.